This is Unit 2, Day 2, Part 1. Example 9. A circular garden with a radius of 15 feet is to be covered with topsoil at a cost of $1.25 per square foot of a garden space. Determine the area of the garden to the nearest square foot. Show your work. Okay, so the things you have to pay attention to. It does say circular, and it wants area. So you have to know that area of a circle is pi r squared. Okay, it did tell us up at the top here that the radius is 15 feet. So you're just going to substitute into the formula. It would be pi times 15 squared. Just go right to your calculator, and the calculator is going to give you 706.858. Now it does say nearest square foot, so you're going to round to the nearest whole number. So the area is approximately 707 square feet. Part B, using your answer from Part A, calculate the cost covering the garden with topsoil. Show your work. Well, if we have 707 square feet and it's $1.25 per square foot, we're just going to multiply that by $1.25. And you'll get $883.75. All right. Now it starts talking about basically the composition of functions. So there's two really, really important notations that you have to pay attention to down here. These are actually two different notations, but they would be calculated in the exact same way. So you have to know that you're working from either inside out or always working from right to left. So down here, this is the g function. You would always do that first. Over here, most right is the g function. You would do that first. The f functions on the outside are what you would do second. So remember, when you compose something, it just means you have more than one. So a composition of functions is when you're going to plug a function into another function and simplify. Okay, so we have to do g of 1 first. So we're going to go to the g function, and we're going to substitute in a 1, because remember, that's my value of x wherever I see that. So I come up to this g function, and it says 2x plus 3. So I'm going to go 2 times 1 plus 3, and that's going to give me a 5. Now that 5 is the answer right there. So now I have to evaluate the f function at 5. So now when I substitute that into the f function, I'm going to get 5 squared minus 5, which is going to result in a 20. And that is my final answer. Down to letter B here. So you're going to take the f function, and you're going to substitute a 2 in wherever you see an x. So into the f function, it's going to be 2 squared minus 5 is going to result in a negative 1. Now, take that negative 1 and plug it in the g function for x. So it's 2 times negative 1 plus 3, and that's going to result in a positive 1. Down to letter C. You're going to start with a g function, substituting in a 0 into the g function. So it's going to be 2 times 0 plus 3, which is 3. Now take that 3 that you just calculated, and now it wants us to plug it into the g again. So now I'm going to do g of 3. So it's going to be 2 times 3 plus 3, which is going to result in a 9. Okay? Back up top here, a little bit different notation, but you're still working from right to left. So I'm going to plug a negative 2 into the g function. So it's going to be 2 times negative 2 plus 3, which is a negative 1. Now take that negative 1 and substitute it into the f function, so they want you to find f of negative 1. Remember, any negative numbers plugged in have to be in parentheses so that you know it's the negative number being squared. And then minus 5. So that's going to result in a negative 4. Okay, letter E, we're going to do f of 3 first. So substitute in a 3 wherever you see an x in the f function. So it's going to be 3 squared minus 5, which is a 4. Now take that 4, and you have to find g of 4. So it's going to be 2 times 4 plus 3, which is an 11. Last one here, f of negative 1. Again, a negative number, make sure you use parentheses. So it's negative 1 squared minus 5 is going to be a negative 4. Now take that negative 4, and it wants you to substitute it back into the f function. And again, another negative number. So it's negative 4 in parentheses squared minus 5. And that's going to result in a positive 11. Okay, moving on to example 11. These are actually really nice. We're doing the same thing, but you're looking at a graph for its values. Now don't forget, if you have f of x equals y, that's your x value, that's your y value, you get the coordinate x, y. Okay, so for letter A, so we have two graphs here. We have the f function graph and we have the g function graph. So it looks like the f function is linear and the g function is quadratic. So f of 2. What that means is x is 2 in the f function. So you're going to go over till 2. So here's my 2 on the f function, and then I'm going to go up top, and it results in a 3. So that inside part is a 3. Now I have to find, so let me write that out for you. So f of 2 is equal to 3. Now I'm going to use that 3 and look at the g graph, and I have to find g of 3. So I go over to 3. On the g graph, I go up, and I have a 3. So my final answer is a 3. Okay? B. B, you have to find g of negative 1. So go to the g graph and go over to x equals negative 1. And if I look at the graph over here, here's negative 1. I go down 1, 2, 3, 4, 5. So my answer is negative 5. So now I have to find f of negative 5. So go to the f function graph and go over on the x-axis at negative 5. And this one's kind of in between, but if you go at negative 5, it looks like it's at negative a half. So there's my answer. Part C, g of 1 first. Looking at the g function, go over to x equals 1, and you're going to get a 3. Now take that 3, and it wants it back in that g function. So now you have to go over 3 on the g function on the x-axis, and if you go over 3, it is up 3. So my answer is 3. Letter D, g of 0. So you're right on the origin there. So g of 0 is 0. Now take that result. So now you want f of 0. So if I go to the f graph here, if you need a little help, here's f of 0 right here. It'd be up at positive 2. Letter E, you're going to do f of negative 2 first. So go to the f function graph, go over to negative 2 on the left, and you're going to go up to a positive 1. Now evaluate g of 1. So on the g graph, go over to 1, and it's up at positive 3. Last example here, we have f of 0. So f at 0. So remember, you're not moving left or right on the x-axis, so you just go up. It's your y-intercept. You're going to get a 2. Now evaluate f at 2. So 2 is your x value, so go over 2 to the right on the x-axis on the f function graph, and it would be up at positive 3. Example 12. On occasion, it is desirable to create a formula, okay? Okay, keyword there's formula for the composition of two functions. So basically, we have to plug the g function into the f function. So here's my g function. So I box it in, or you could use a set of parentheses, and that has to get substituted into the f function wherever you see an x. So that one becomes 3. Now remember, you don't write x, you're going to write 5x plus 4 minus 2. So now I'm just going to simplify. So I'm going to distribute, and I get 15x plus 12 minus 2. That simplifies to 15x plus 10. So there's my formula for f of g of x. Okay, now letter B is the reverse. Letter B says take the f function and plug it into the g function. So I'm going to take this f function here, and I substitute it into the g function wherever I see an x. So that is going to be 5 times the whole quantity, 3x minus 2, plus 4. Again, simplifying. So I get 15x minus 10 plus 4. One last step simplifying, I'm going to get 15x minus 6. So that's my formula for g of f of x. And you can see they're not the same. Okay, so order matters here. Example 13. Doing the same thing, it's multiple choice. So I have to take the g function and I plug it into the f function. So here's my g function, and that goes into my f function. So be careful with this one. So it's x squared, but don't forget, my x is the quantity x minus 5 squared. So my visual learners, you might have to write that out, and you're either going to FOIL or use the box method. So that's going to result in x squared minus 10x plus 25. Okay, I did my outers and my inners in my head. So that's going to be choice 4. All right, the next topic in this day is domain and range, okay? You did learn this in your algebra class, but you have to know that your input value is x and your output value is y. You also memorize domain is always representing x and range is always representing your y's. You must know that, okay? So it says state the range of the function f if its domain is the set 1, 3, and 5. So now remember, they just said domain. Domain means the x's. So that's telling us let x equal 1, let x equal 3, let x equal 5. So we're going to go to the function, and we're going to find f of 1, because that's what it wants us to do first. So you go to that function, and you're going to do 2 times 1 plus 1, and that results in a 3. So I'm going to use set notation, curly brackets here. And when x is 1, my range, my y is 3. And then you're going to do the same thing for the other values. So you're going to evaluate f at 3. So it would be 2 times 3 plus 1, which is a 7. So 7 is my second range value. And the last one, f of 5, would be 2 times 5 plus 1, which is going to result in 11. So my range for this function is 3, 7, and 11 when the specific domain is 1, 3, and 5. Now it says show that the domain and range in a mapping. Okay, so mapping means you're drawing them. I usually just keep them in numerical order. So my x values, right, were 1, 3, and 5. My range values were 3, 7, and 11. Now it does say mapping. So 1 maps to 3, 3 maps to 7, 5 maps to 11. And if you guys notice, these also are coordinates on that graph. So if you were to actually graph that linear function 2n plus 1, these would all be coordinates of that graph. Okay. Example 15. It says the function y equals g of x is completely defined by the graph shown below. Answer the following questions. Okay, so they just give us this graph. Determine the minimum and maximum x values. Okay, so now with x, remember, x goes from left to right. So the lowest is the minimum. So you look at that graph, and the value most left, the minimum, is going to be -3. Okay? And if you look at my yellow highlighter, the maximum would be the value that's greatest to the right is going to be 6. Okay, so these yellow lines are at -3 and +6. So it's minimum, maximum. All right, now we're going to do the same thing for the y's. Now remember, y runs up and down. So here's my minimum, and here's my maximum. So it's the lowest and the highest on the y going up and down. So my minimum value looking at that graph is -5, and my maximum value is +4. Part C. State the domain and range of this function using set builder notation. You guys have to memorize anytime it says set builder notation, it means curly brackets. So domain is x, so it means for all x such that. That's what that horizontal line means. And then it's between, x is between -3 and 6. So you use your part A there. Okay, it's always less than or equal to when we're going from least to greatest. You can do the same thing for the range, but it's for all y such that -5 is less than or equal to y less than or equal to 4. Okay, so there's my set builder notation for domain and range. All right, now this next box just has some really, really important things that you need to read through. But anytime it's talking about interval notation, they're talking about, I call these square brackets versus smooth brackets, okay? You have to know the square brackets include the number, okay? So if you read that, it says the square brackets are included, and then the smooth brackets or the parentheses are not included, which means they're excluded, okay? And then something else that's really, really important, infinity is never included, so those are always smooth. All right, so now when I go on to the last example here, example 16 says the function f of x equals x squared minus 2x minus 1 is graphed on the grid below. Which of the following